These are the notes for Lesson 91. Lesson 91 for Algebra 1. Lesson 91 is due Tuesday, April 21st. But before I do Lesson 91 notes, I want to go over a couple from Lesson 90 that several of you missed on the homework. Number 9 is one of them. Its absolute value, I think it's an n, I put an x. It's number 9, and its absolute value of n plus 3 plus 4 equals 4. So you need to make sure you write these down in your notes because I'll be looking for them because I want to show you what happened on this one. Most of you that I saw, you subtracted 4 excellent. Like you got that, you isolated the absolute value. That was great. Then here is where you messed up. Some of you put like an n plus 3, n minus 3. You're not supposed to change the sign in the absolute value. You're supposed to change the sign on this number. The issue is 0 cannot be negative. So you just have one equation instead of 2 to solve. So n equals negative 3. That's the only thing you should have gotten, okay? Again, don't change the sign on what's n on the absolute value. You only change the sign on the number on the outside, like 0, and like I said, 0 can't be negative. So you just set n plus 3 equal to 0 and then subtract the 3, okay? Then I also wanted to talk about number 13. Number 13, you've got that a marine biologist needed a sample of wild sardines from the northern Pacific. In his analysis of the sample, the average length of the adult fish was 210 millimeters. Then he noticed that the greatest variation in length from the average length was plus or minus 33. So all you should have done to find the maximum and minimum is done 210 plus 33, 210 minus 33. That's what I showed you when we took notes on this lesson. So 243 millimeters and 177 millimeters. Some of you tried to set up the absolute value equation, which I told you not to when we went over this lesson. So this is what I want to see on a problem like that. So make sure you're careful with that, okay? Now on to doing the notes for lesson 91. Okay, so in lesson 91, we're dealing with absolute value again, but we're dealing with absolute value inequalities. So you're going to see something like this, absolute value of x less than 4. So just as a reminder, if I have absolute value of x equals 4, x can be plus or minus 4. So you're doing the same thing here. You're going to have a plus or minus 4. The difference between this one and when it's equals is the way you write your answer. And you also have to graph this, okay? So you need to know that when you've got absolute value less than, it's called a conjunction. And you are going to have, when you write your conjunction, you're going to have a number less than x less than another number. That's how you write the conjunction. Then when you graph it, you're going to have those two numbers on your graph, and you're going to shade in between, okay? So that's the way a conjunction works. And when it's absolute value less than, it's a conjunction, so it works like this. So again, absolute value of x, just like up here, so I've got a plus or minus 4. So my two numbers here, x can be plus or minus 4. Now the difference is, if it was equals to, we'd leave our answer like this, but it's not, it's less than, so we have to write the conjunction. So we put smaller number on the left, bigger number on the right. There's no equal to bar, so I don't put an equal to bar here. And then on the number line, I put negative 4, I put positive 4, open circles because there's no equal to bars, and I shade in between. So there's your conjunction. There's your absolute value less than. So that's the way an absolute value less than works, or a conjunction. So then you can have absolute value of x greater than 7. So when it's absolute value greater than, you have what's called a disjunction. You have a disjunction. So on the disjunction, you're going to have x less than a number or x greater than a number. And you have to make sure you put the or it's not a correct disjunction. Then when you graph it, you're going to have the number sign, open circle, or closed, depending on the equal to bar. You'll have the other number, and then you're shading out this way, which we've worked with and graphed ors and disjunctions before, okay? And it's what we've got to use when we've got absolute value greater than. So absolute value of x is 7. That means x can be plus or minus 7. I like to call these our boundary numbers. So to write the disjunction, x is less than the smaller one, so x is less than negative 7, or x is greater than 7. So then putting this on a number line, open circle because we don't have an equal to bar, then 7 open circle. And so there's your disjunction. There's the solution and the graph. You have to graph these. Now again, think about it. If I take -8, which is less than -7, and put it right here, -8, absolute value of -8 is 8. 8 is greater than 7, so that's why these numbers work. That's why these extremes work, okay? Then we've got the, let's just do another one of these right quick. Absolute value of x is less than 2.5, so it's a conjunction because it's less than. My two numbers are plus or minus 2.5. So, whoops, got a little ahead of myself. So we put -2.5 less than x, less than 2.5. And notice, they're both less than signs. Some of you put a less than sign here and then a greater than sign here. You can't do that. They're both less than signs. So be real careful when you're writing these, because it doesn't make any sense if you don't write them like this. And then there's the graph, okay? And let me show you one more disjunction before we expand on this. So here I've got absolute value of x is greater than or equal to 10. This is a disjunction because it's absolute value greater than. So my two numbers are 10 and -10. So x is less than or equal to the smaller one, or x is greater than or equal to the bigger one. Again, the only difference between these and if it's just an equal sign right here is the way you have to write your answer. So there's the disjunction. Here's -10 with the closed circle and shading to the left. Here's +10 with the closed circle and shading to the right. Okay, so now let's expand on this. And you will see problems where you have to isolate the absolute value. So absolute value of x plus 7.4 is less than or equal to 9.8. Absolute value of x plus 7.4 is less than or equal to 9.8. So you're going to subtract 7.4. That's going to give you absolute value of x is less than or equal to 2.4. Then it's a conjunction, so your two numbers are positive and -2.4. It's a conjunction because it's absolute value less than. So 2.4 -2.4, positive 2.4, closed circles on both, and shading in between. So there's your conjunction. And that, again, is just having to isolate the absolute value. So we added a number. You might have to subtract a number. You might have to multiply by a number, divide by a number. So we're going to look at all those kind of examples. So absolute value of x minus 2.2 less than or equal to 7.8. Absolute value of x minus 2.2 less than or equal to 7.8. So we add 2.2. So that gives absolute value of x less than or equal to 10. Or 10.0, or you can just put 10. Again, it's a conjunction because it's absolute value less than, so my two numbers are plus or minus 10. So I write my answer as a conjunction because that's what happens here. So there's my conjunction, and then here's graphing it. Closed circles because there's equal to bar, and you're shading in between because it's a conjunction. So it's all the numbers in between -10 and 10, and actually -10 and 10 work because you got equal to bars. So if I plug in 0, it's going to make it true because absolute value of 0 is 0 and 0 is less than 10. If I plug in -2 that's in here, -2, absolute value of -2 is 2, 2 is less than 10, so it works, okay? So that's an adding or subtracting. Then you can have where you have to multiply or divide. So absolute value of x over 4 is greater than 2. Absolute value of x over 4 is greater than 2, so you're going to multiply both sides by 4. And absolute value of x is greater than 8. Do not change this inequality. I multiplied by a positive, so don't change the inequality. So this is a disjunction. So my two numbers are plus or minus 8. So it's a disjunction. So x is less than -8, or x is greater than positive 8. So -8 open circle shading to the left. Positive 8 open circle shading to the right. The disjunction. There you had to multiply by a number. Let's try another one. Absolute value of x divided by -3 greater than or equal to -9. Absolute value of x divided by -3 greater than or equal to -9. So I'm going to get rid of this -3. I'm dividing by -3. So I'm going to multiply both sides by -3. I'm multiplying by a negative, so flip the inequality. That's one of the biggest things you have to watch out for. Flip that inequality when you're multiplying or dividing by a negative. So this is a conjunction because I had to flip the inequality. So x is plus or minus 27. So it's a conjunction, negative 27 to 27. I keep wanting to graph it first. So here's my conjunction with equal to bars because I started with equal to bars. Now I graph it, negative 27, 27. And some of you don't put your numbers on your number line. You need to make sure you put your numbers on your number line. You've got to put your numbers on your number line on this. Okay, you always need to put them on there, but especially on this. Okay, so those were multiplying. Now let's look at some dividing where you'll have to divide. So let's see, negative 2 times the absolute value of x less than negative 6. So I've got to divide by negative 2 to isolate that absolute value. When I divide by a negative across an inequality, I flip the inequality. So this becomes a disjunction. So my two numbers are plus or minus 3. So x is less than negative 3 or x is greater than 3. And then I've got negative 3 open circle shading to the left, positive 3 open circle shading to the right. That's a disjunction. That's a dividing one. Let's see another dividing one. 3 times the absolute value of x is greater than 2.7. So again, I got to divide by 3. I don't change the inequality because I didn't divide by a negative, so that leaves me 0.9. So x is plus or minus 0.9. It's a disjunction because it's absolute value greater than, so x is less than negative 0.9 or x is greater than 0.9. So when I graph it, negative 0.9 open circle shading to the left, 0.9 open circle shading to the right. Okay, then one more type you're going to see. And it's going to look like this. Absolute value of x minus 5 is less than or equal to 3. So what you have to do here, this is already isolated, it's already by itself. You know it's going to be a conjunction because it's less than or equal to. So you've got to make your two little equations. Oh my goodness, I messed it up. You've got to make your two little equations where x minus 5 equals 3 and x minus 5 equals negative 3. Notice I am not using inequality signs here. Do not use inequality signs here. It will mess you up. That is the one inequality sign. It's already telling us it's a conjunction. So here use equal signs to find your boundary numbers, just like we've done before. So one of my boundaries is 8. My other boundary is 2. So then this is a conjunction. I already said it's a conjunction. So 2 less than or equal to x less than or equal to 8. So 2, 8, closed circle, and everything shaded between. Okay, so the difference is here how you find your boundary numbers, but we've already done that when we had absolute value and equals. Okay, so just make sure that you do not use inequalities when you're finding your boundaries. So this is going to be a disjunction right off the bat because my absolute value is isolated. I have something on the inside but nothing on the outside, so it's going to be a disjunction. So to find my boundary numbers, I set x plus 7. Notice I do not change the x plus 7. Some of y'all are changing this sign. Don't change the x plus 7 sign. You change the sign on the 3. So x plus 7 equals 3. X plus 7 equals negative 3. So subtract 7. I get x equals negative 4. That's one boundary. Subtract 7 here, negative 10. Okay, this is a disjunction. So that means x is less than negative 10. It's less than the smaller one, or x is greater than negative 4. So then on the disjunction, negative 10 open circle shading to the left, negative 4 open circle shading to the right. Okay, let's do just a couple more of those just to make sure you're really careful, and I show you again which sign you need to change. So this is going to be a conjunction again. It's a conjunction. So I find my boundaries. X plus 4 equals 5. X plus 4 equals negative 5. Again, do not change the x plus 4. Do not change the x plus 4. Don't change the x plus 4. Change the 5. Because whatever's in absolute value can be 5 or negative 5. Because when I take the absolute value of 5, I get 5. If I take the absolute value of negative 5, I get 5. So it's this part, this x plus 4, that can be 5 or negative 5. So then subtract 4, so x is 1. Subtract 4, so x is negative 9. Conjunction, negative 9, less than or equal to x, less than or equal to 1. Negative 9, 1, close circle, shade in between. Conjunction. Okay. Then let's see, x minus 2, absolute value of x minus 2 greater than 3. This is a disjunction. So then x minus 2 equals 3, x minus 2 equals negative 3. Again, do you see how I did not change the x minus 2? I changed the 3. So then when I add 2, I get x equals 5. And I add 2 here, I get x equals negative 1. Disjunction, because it's absolute value greater than. So x is less than negative 1 or x is greater than 5. So graphing it, negative 1 open circle, less than, 5 open circle, greater than. Okay, then I want to show you a couple of special cases. Special cases, absolute value of x plus 6 less than or equal to 4. So if I subtract the 6, absolute value of x is less than or equal to negative 2. Absolute value is always positive. This is always a positive number when you take the absolute value. So it cannot be less than a negative 2. So this is no solution. That's that no solution sign. So when you've got absolute value less than a negative, it's no solution. Then the other way is if you, we'll just switch the inequality. If I subtract 6 here and I get absolute value of x greater than negative 2, this is all reals. That's all real numbers because absolute value is positive and positive is always greater than a negative. So these are your two special cases that you need to watch out for. You might get a no solution, you might get an all real. So watch out for those special cases. You'll see them on the practice. And then one other thing I want to show you is the way I want you to work something like example 5, which is like practice J. So this is what I want to see on practice J, and I'm going to show you example 5, and this is what I want you to do on practice J. Okay, a poll finds that candidate Garcia, this is on page 605. A poll finds that candidate Garcia is favored by 46% of the voters surveyed, and Jackson is favored by 44%. The poll has an accuracy of plus or minus 3. A says to write an absolute value inequality. I do not want you to do this. Do not write the inequality. I don't want that. I want you to do it like we've done before, where you just do plus or minus. So on B it says, solve the inequality to find the range for the true percentage of voters for Garcia. So Garcia is 46%, and it says there's an accuracy of plus or minus 3. So plus or minus 3. So 46 plus 3, 46 minus 3. That's 49% or 43%. That's all I want to see. It's just like finding the maximum, minimum, and it's just like number 13 that I showed at the first of this video, okay? This is the way I want you to work J. This is J right here, practice J. This is what I want to see. Do not write the inequalities. If you write the inequalities, I'm going to count off, okay? Because I want you to do it this way. It's faster, it's easier, it's quicker, it gives you the answers. Writing the inequalities, I think, would just confuse you, and I don't want to confuse you, okay? And this is the way you can find this, the maximum and minimum. Okay, so just do this, and plus the fact I want you to follow instructions. So those are my instructions, so make sure you follow them. Okay, so let me give you the assignment, and there's a few I want to show you out of the assignment, especially some factoring ones, because some of you are needing some work on your factoring. So let me make the assignment. Don't forget to do the warm-up. A few of you on lesson 90, you forgot to do the warm-up and had to go fix it. So don't forget to do the warm-up. It's on page 602. Then you're going to do the practice A through H and J. Do not do I. I don't want you to do I. I is writing that absolute value inequality that I don't want you to do, okay? And I've just shown you how I want you to do J. Then you're going to do 1, 4 through 8, 11, 12, 16, 19, 20, 21, 22, 23, 28, 29, and 30. Okay, and I'm going to go through some of these with you. I'm going to talk about them. Okay, again, this is not due until Tuesday. You've got test 16 and review 16 that's due Friday, so make sure you're working on those. And let me go over just a few of these with you right quick before I let you go. Okay, so let's see. Number 1 is just finding the axis of symmetry. The thing you need to remember about number 1, it's negative b over 2a, and you've got to put x equals. You've got to put that x equals. Several of you missed that last time. Number 4, negative 4y to the 4th plus 8y cubed plus 5y squared minus 10y. So this one you can do factoring by grouping. So I'm going to go ahead and work this with you. Here, since that's a negative, I'd go ahead and take a negative. So I'm going to take a negative 4y cubed. That would leave y minus 2. Then on this next one, I'm going to take a 5y. And that'd leave y minus 2. So then right here, negative 4y cubed plus 5y, that's 1 factor, and then y minus 2. A lot of you would stop right here, which is incorrect because this still has a common factor. You can still take a y out. So I can take negative y. So that's going to leave 4y squared plus 5, and then y minus 2. Okay, I wanted to show you that just to help you on your factoring because you've got to get the factoring, okay? Then number 5 has 3a squared minus 27. So if you'll take a 3 out, that leaves a squared minus 9. That factors in the difference of 2 squares. A plus 3, a minus 3. So again, they're seeing the difference of 2 squares. They're seeing factoring out a common factor. So that's number 5. Then I also want to show you number 6. There's actually a couple of different ways you could do number 6. What you could do is take a common factor out because there's a 2 in all of them. So that will leave 2x squared minus 3x minus 2. Then you've got to do that advanced factoring. 2 times negative 2 is negative 4. So I need the factors of negative 4 that give me negative 3, which would be negative 4 and 1. So 2x squared, and a lot of you need practice on this type of factoring. That's why I'm doing it with you, because you need practice on it. So we take 2x out, it's x minus 2. We take a 1 out, it's x minus 2. So I would have x minus 2, 2x plus 1, with the 2 that I took out way up here. So that's my final answer on number 6, okay? Not the only way to factor that one, but I think that's the best way. I think that's the easiest way. Did I write? Oh, guys, I wrote the problem wrong. So all that has to happen is I'm going to change signs. That should have been a plus. I put a minus. So this should be a plus. I put a minus. So this should be a plus. This should be a minus. Sorry, guys. So this is going to be a plus now right here. I'm going to take a negative 1 out. That makes that a plus 2. When I take a negative 1 out, it makes that a plus 2. So this should be a plus 2. This should be a minus 1. Yeah, that should have been a plus 6 because I wrote it incorrectly. So don't do what I do. Don't write them incorrectly. Let's see, the number 7, 9x squared minus 2x minus 32. So this you do 9 times negative 32, that gives you negative 288. 9 times negative 32 is negative 288. Then you're going to use negative 18 and positive 16. So then 9x squared minus 18x plus 16x minus 32. So then take a 9x out here, that's x minus 2. Take a 16 out here, that's x minus 2. And you need to finish it from there. Well, I'll just finish it. It's 9x plus 16, x minus 2. That should have been an x minus 2. Okay, then there was another few I wanted to look at. Nineteen's axis of symmetry, so you make sure you use the negative b over 2a. On 20. On 20, this is from lesson 89. If you'll go back and look at your last practice one on lesson 89, it will help you with this. What you're going to do, they want the maximum height. They actually just want the maximum height. And the time it takes. So to find the time, that's negative b over 2a. They give you negative 13x squared plus 39x. So here's your a and here's your b. A is negative 13, b is 39. And you're going to use negative b over 2a. That's going to find the time. Once you find that, actually they've got an x here, so let me put an x. Once you find that, then plug in to find the height. So once you find this negative b over 2a, once you find that number, plug it in to find the height, okay? Plug it in right there for x and right there. Be very careful. Make sure you square it like you're supposed to. You cannot get a negative time. If you get a negative for x, you've messed up. You cannot get a negative time. So once you find this, plug it in to find the height. Look back at lesson 89. The last practice one on lesson 89. You can look at it, it'll help you, okay? Then on 21 and 22 both, you got to use the distance formula, which some of you are still messing up your distance formula. So I'm going to write it again. You need to write it every time you use it, just like Pythagorean theorem. There is your distance formula. x2 minus x1 all squared plus y2 minus y1 all squared. There's your distance formula, okay? So you're going to plug in the 2 points they give you on the distance formula, and then it says each grid represents 0.05 miles. So once you get the distance, multiply by 0.05. And then, if you need to, just find this as a decimal, then multiply by 0.05, write your answers, make sure you label it with miles, okay? But you multiply by 0.05. Then 22 is also finding the distance, but on 22, I think they say each grid represents 0.25. So you're going to take your distance and you're going to multiply by 0.25. And this says to the nearest tenth, so make sure you round it to the nearest tenth. That's one decimal place. That's one place after the decimal. And then make sure you label it with feet. Okay, so that'll help you with 21 and 22. Then let's see. Number 28. I want to talk about 28. It's y equals 1,000 over x plus 20, okay? So on A, you want the horizontal asymptote. The horizontal asymptote is this extra number out here, so y equals 20. That's your horizontal asymptote. B is your vertical asymptote. Your vertical asymptote is taking the denominator and setting it equal to 0, so x equals 0. Notice I put y equals 20, x equals 0. Got to be in linear form. Then on C, if the price of the t-shirts is $10, so that means you're going to put in x equals 10, and you're going to work it out. So you're going to plug the 10 in right there where the x is, and you're going to work it out. So I'm going to leave you to finish C, okay? Then 29 is factoring. 29 is 4x squared plus 9x plus 2. So I'm going to start you on this, and you're going to need to finish it. 4 times 2 is 8. The factors of 8 that give you 9 are 8 and 1. So 4x squared plus 8x plus 1x plus 2. And then you should be able to go from there. Take a 4x out of these two and write down what's left. Take a 1 out of these two and write down what's left. And then finish the factoring. That'll get you on 29. And then 30 is not a big deal. Let me go back to 21 and go ahead and do this distance formula since some of you are having a hard time with it, just to show you. So this will help you. Okay, so there are my 2 points. So my x's are 5 and 7. So 5 minus 7 all squared plus 3 minus 10 all squared. So negative 2 squared. Notice I'm putting parentheses around the negatives. A lot of y'all are not squaring your negatives. You have to square your negatives. It's squared. You should never have a negative underneath this radical because you're always squaring them out. So this is 4. This is 49. So that's the square root of 53. And some of you are forgetting to find that square root of 53 correctly, okay? So you're going to find that on your calculator. You're going to find the square root of 53 on your calculator, and you're going to multiply by 0.05, okay? Okay, so that'll finish it up. So that's walking you through the distance formula again. And then you're multiplying by 0.05, and then 22, you're going to do this and multiply by 0.25. And again, it's due Tuesday, the 21st.